Dear Professor Dikitmain Nitam and other faculty member, I would like to present my homework 5 number 2 from the C# book example 3.3 using gyro sensor, especially for MPU 6050 to read the XYZ value. This is my presentation. My name is Nugroho Budi Wicaksono. And the goal is making this one the GUI, graphical user interface, and with the component of connect button to connect the Arduino to the graphical user interface of C#, and then it will use the combo box also to identify the available communication port. This one is the combo box, and it show unavailable because it was said that there is no available communication port. It will show unavailable, and then we have three text box to show the value of x-axis, y-axis, and z-axis. And for the hardware, I use the gyro sensor of MPU 6050 and Arduino Uno. And for the software, I use the Microsoft Visual Studio Community 2022 and Arduino IDE 2.3.2 with the dependency of wire.h, which is a communication library for I2C device. And because of that, we need to mention that the gyro sensor of MPU 6050 uses I2C communication. We need to connect it with SDA and SCL pin in A4 and A5. A little bit about MPU 6050. It has both 3-axis accelerometer and 3-axis gyroscope integrated on a single chips. It usually also called as 6-axis motion tracking device or 6DOF or 6 degree of freedom because of its 6 outputs, and those 6 outputs are 3 accelerometer outputs and 3 gyro outputs. And I need to mention also that the keywords to know about the MPU 6050 is about it uses the MEMS technology and the Coriolis effect. So the Coriolis effect is when this one when we see the camera from the above and the people on the seesaw is rotating and one of them is throwing the ball, and we can show that the ball trajectory is like this, is aligned, like a line like this. But when the two peoples moving on the seesaw, circular, and also the camera from the above of them is also moving, then we know that the trajectory of the ball is not straight like this one. It will become bended like this one. It's like a circular path. And then the sensor can measure the gravitational acceleration along the 3-axis, and by applying from trigonometric calculation, the angle of the sensor's position can be determined. By fusing or combining the accelerometer and gyroscope data, it is possible to obtain highly accurate information about the sensor orientation. In short, accelerometer sense change in speed and direction, gyroscope sense rotational speed. And this is the schematic. As I said before, the MPU 6050 will use the I2C, SDA, and SCL to communicate to Arduino. So we need to connect to A4 and A5. And for the VCC, we need to connect to the 5 volt, and for the ground, we need to connect it to ground. This is the GUI for the RMUTT Explore MPU 6050. We have the connect button and COM port, and this is the text box. The COM port need to be set as follows, and the action, for the action we need to read data from Arduino, and the timer we need to use the timer 1 tick. I will explain it on the C# code. And this one, the C# code, this is the GUI, and this is the GUI. We have button, we have combo box, we have 3 text boxes like that, and this is the code. The value from the text box is stored on the compass like this. So it used the array of strings, and the value of the array is, it has 3 value, which is for the x, y, and z value. And and then we need to convert the string to number using the number is stored as a double. The data type is a double, so it will convert the string to number like this. This is the text color. We need to set the back color like that. And this one is the function read data from Arduino, as shown in this one. Read data from Arduino, and then the read data from Arduino used to store the data from the reading of Arduino, the data that is sent from Arduino to the C#, until they have the \r and \n, and then it will split the data if we have comma character like that. We will see it on the Arduino code. In the Arduino code, because the sending data, we need to include this one, so it can be separated from the whether it is x, y, or z value like that. This is the function of this character, and this is the component initialization, and this is the button click. It used for selecting the combo box to connect to Arduino as port number, as a certain port number. Okay, that's for the C# graphical user interface, and this one is the Arduino code. So we use this one, but it's already embedded on the Arduino IGE, that so we need doesn't need to install again. And the address for MPU 6050, I2C address is 0x68, which is 68 in the hexadecimal. And as in the introduction before in this one, we have the MPU has 3 axes of accelerometer and 3 axes of gyroscope. So we need to declare this one. For accelerometer, I use float, and for integer, I use for the gyro, I use integer. Okay, this one is the setup. We need to set the serial communication as 6600 bps per second, and then this is the communication for wiring library to communicate using the I2C protocol. And then for the loop, we need to set the transmission to the MPU and write the register with the number of 3B in hexadecimal. And then we read the X, Y, and Z value. We need to divide the raw value by 16,000 and 384 because we follow the function in the datasheet like that, and we need to read the gyroscope data, so we need to use the tick command like that. We need to store the current time to previous time and current time to same as millis and so on like that. And finally we have the value of x, y, and z like that. So this is the video of the demonstration. This is the MPU. This is the MPU 6050, and then this is the code. I will start it, and after it started and I connect it to pin 5. So we need to identify that whether it's correct or not. It is pin 5 or not. Sorry, this is COM port 5 or not. We need to set it on the device manager, and after that, after we click connect, we can see the reading of the X, Y, and Z value of that. When we try to turn, we try to pan it backwards, pan it forward like that, the value is uh, changed. The value are changed. Okay, that's the demonstration video of this homework. Thank you so much for your kind attention, and so you see you in the next video.